Okay. Okay, to 2 days. Guys, then please remember that your talks, which is going to be by next week, I record only your talks. Then if you are interested, you can request, you send an email to me. I give you back, email you back your recording of your talk. Then that's going to be a great thing. Then you can keep it. If you want to go somewhere, change school or anything, you can show that as a portfolio that you have talked on the talk we're just going to have is a very advanced talk. Then it means that you are going to do something incredible. Then it's good to have it with yourself. Okay, the talk which you're just going to have is not very easy. It's a very sophisticated stuff. Then it's good to keep it as a portfolio. Okay, speaking of which, now we're just going to go back to the trigonometric equation which we started, I should say, yesterday, and try to solve some equations. Okay, now I'm just going to start by this. I'm gonna let's do this one. I have this one 2 times of cosine x sine x minus cosine x equals to 0. Everyone can see what I have written there in terms of the light?
Yes.
It's clear, huh? 2 cosine x sine x minus cosine x equal to 0. Okay. Okay, now I'm just gonna start working on it now. And please you follow the way which I do, because there is a very important, I should say, very smart trick for this very specific equation. Then I ask you, please, everyone, listen very carefully. Okay, guys, look at this. This expression. We have 2 terms for this expression. The first term which we have for this equation, it's 2 times cosine x sine x, and the second term is cosine x. This equation is essentially this. You may come to ask yourself that, okay, I can very easily solve it like that. Give me 1 second to see that if I have done something similar for you yesterday. I do not repeat the same equation. Okay, it seems no, I haven't done that. Okay, it's something new then. Guys, look at this one. You may be given this equation. There are 2 possible scenarios to approach this trigonometric equation in order to find a complete set of solutions for the x. That's the goal. The first approach that you may think of is this. As a possible approach, you may think that you come here and you say, because I have minus cosine x, I can take cosine x to the right side of the equation, then its minus becomes plus. Then what do I have with? It becomes 2 times cosine of x sine x should equal to what? Should equal to cosine x. Look at this one, guys. That's one possible scenario. And you take a look at both sides, you see the term cosine x, which is repeated. You have 1 cosine x as a product of 2 terms. On the left, you have both cosine x on the right side. Then based on the things which you have seen before, you may come to ask yourself that I can probably remove these 2 terms from these 2 sides because they are equal. and come to an end with this simple equation. On the left, I'm only left with number 2 and also the sine x. And on the right, I'm left only with 1 because I removed cosine x. It means that you divided both sides by cosine x. Then on the right, this is cosine x divided by cosine x. Then it becomes 1. And also to the right, it becomes 2 times sine x. And you say, okay, as long as I'm there, I can come here to write this in this way. Write it as a sine x should be equal to what? Should be equal to 1 over 2. Correct? Then it remains for you, from the things that you learned before, still you may think that you are doing the right thing. To say that, okay, in that case, then x is going to be easily found because you say that x, it becomes, if you take from both sides the inverse of the sine, it becomes, let's say, the sine inverse of 1 over 2, which you know it becomes, as a reference angle, becomes pi over 6. It is one possible method that you may think to do in order to get there. Do you think it's a correct approach? Then from here, definitely, we can end up with this to say that x is going to be pi over 6 plus 2n pi. N can be any number from 0 to plus or minus 1 or plus or minus 2, goes all the way to infinity. But the question is that I use this method, and by using this method, I derived this equation, this solution, that x is equals pi over 6 plus 2n pi. But do you think that that is a right method? What do you think of it? No idea? Anyone? Gloria, Rose, Ferris? Nobody has an idea? If you have no idea, let me say, guys, this method sounds correct, but there is a problem with it because that's the method which we used yesterday when we talked about solving a trigonometric equation. But I have to stop you at this stage that we removed cosine x from both sides. In the past, you know that if you had, for example, any algebraic number, if I had 2 from both sides, it was okay if I just divide both sides by 2 and simplify my equation. But when I have cosine x, if I remove cosine x from both sides, then I have removed one important member of my trigonometric equation. And by doing so, it means that I have eliminated a set of information and a complete set of solutions from my main equation. It means that, for example, this equation has 2 hands. By eliminating cosine from both sides, you cut one of the hands of that person, and that person has left with only one arm and just only one arm and hand. And the left arm, for example, has been amputated, and you have just cut that arm. And essentially, if you thought of this method, that you can take cosine x to the other side and divide both sides by the cosine to get rid of cosine to end up with this simple term, then I have to tell you, my friends, this method is completely wrong. That's why I'm just drawing here red cross on it, because it's not a right solution. You got why? You got the concept, everyone?
Yes.
Yes. And now let's solve this equation without removing cosine from both sides. I'm going to go to the next page and it starts from there. Okay, now I know at this stage that I shouldn't have removed cosine from both sides. Now, I write it here again. It was 2 times sine x cosine x minus cosine x was equal to 0. Let's start over. Okay, now let's start from here. Guys, again, look at this. This trigonometric equation, as we talked, it has 2 terms involved on the left side. 2 times sine x cosine x, and you have also cosine x. And also look at this. The cosine x, it's a term which is common in both of the terms. Then the thing which we have seen so far, it's sometimes very convenient to factor the term from 2 expressions which they have similar terms. And if I want to follow that prescription, it's going to be like that. I say, okay, cosine x, it's common in 2 terms, then naturally I have an instinct for it to factor the term which is common, which is cosine x. And if I factor this, for the first term, what I'm left with? 2 times sine x. How about what I'm left from the other side? I'm left with minus 1. Because cosine has been factored from both terms, and I'm left with this equation. So far, everything seems smooth. So far, everything seems right. Then I'm going to take the second step. Now, I'm going to take the second step. By doing what? I'm going to take the second step by looking at the terms which I have. We also talked about that yesterday. What did we talk yesterday? We said that if you have 2 terms, for example, look at that, A, B, they are multiplied together and they are 0, it essentially means that either A is equal to 0 or B is equal to 0. And also we talked about that yesterday. It means that when 2 expressions, it doesn't matter how much length they have, they are multiplied together, A times B, then in that sense, and they become 0, it gives you the clue that either A should be 0 or B should be 0. I have the same scenario here. I have cosine x times 2 sine x minus 1 equals to 0. I can look as cosine x as A and the other term as B, which they are multiplied and the result is 0. Now, what else do we have to do? The other thing that we have to do is this. We say, okay, I start from A. I'm going to follow this one to say, okay, now I imagine that A is going to be 0, which it means that cosine x has to be 0. What do? I only take, it becomes step 1 of 2-step solution because I have 2 steps now to take. once I take cosine x goes to 0. The other time I take 2 sine x minus 1 goes to 0. Then I take cosine x becomes 0 as the first step. It becomes solution part 1. If I'm there, based on the things that we learned from last Thursday, we saw that we can take from both sides the inverse of a function. Then we use the fundamental property that the composition of a function with its own inverse gives the x, or the main arguments of that function. Then, if I'm going to do that, I say for the next step, what I'm going to do, I'm going to write cosine inverse of cosine x should equal to cosine inverse of 0. You see, I took only the cosine inverse of from both sides, because I took cosine inverse because I see the cosine x is there. And I needed to use this property that cosine inverse of cosine of the x becomes becomes x. You see that these two functions are from the same nature. Inverse of the cosine, its cosine function, it goes always the main argument. It is here x. It could have been an ice cream, apple, melon. It gives melon, ice cream, apple. Now I have x. Then what do I have here? I have x equals to cosine inverse of 0. That's where I end up. That's where I end up, and that's where I'm just gonna highlight this one. This equation is a very important one. But what's the problem now? We got the x. If you look at this expression, you see that we started from this main equation, and the plan was what? The mind map was what? We wanted to find what is the x itself, not the cosine or sine of the x. What is x itself? And now I have an expression which explicitly shows that the x can be inverse of that. The x is inverse of cosine of 0. But it doesn't mean necessarily I'm done. I brought you an example yesterday. I said that my name is Omid, O-M-I-D. If you read it backwards, you read it Demo. If you call me Demo, I do not understand you're talking to me. But as soon as you reverse my name, you read it forward, say Omid, I respond back, say, hi, what, do you have a question? And that's like that. Inverse of the cosine, it's as if you are reading the name of the cosine backwards. Then as a result, you have to transform it to forward. You call it forward. And essentially, that's what we talked about that many sessions, not almost a week ago. And we said that it is essentially as if asking, what is the angle that its cosine becomes what? That its cosine becomes 0. These two are the same two sides of the same coin. They represent exactly the same thing. However, this way is much easier. It's like naming me Demo, or it's easier to call me Omid. Okay, now I ask you the question, what is the angle that its cosine becomes 0?
Pi over 2.
That's right. Thanks, Rose. You can look at the unit circle. You see that if you are 90 degrees, your projection to the x-axis goes all the way drops to 0, which it means that the cosine of pi over 2 becomes 0. This pi over 2, essentially that's what represents your x. Your x, you named it inverse, backwards, and now you have an expression which expresses that in a normal way, in a forward way. Then as a result, what I'm going to do, I'm going to write the expression as this, as a final answer for step 1. I'm going to write it here. Everyone can see if I write it here? Then
Yes.
x becomes what? Becomes pi over 2 plus, because we are looking for the all answers, 2n pi, which you know n can be 0, can be 1, can be 2, any integer number represents a correct value for this expression. Because when we do that, we only do not get one solution of one circle in the unit circle. Then by adding this term, we are taking advantage of the periodicity of the sine functions, that they rotate around the unit circle infinite number of the times. As the universe goes on, the cosine function and sine functions, all trigonometric function, they continue, they do not stop. And this term actually represents this endless behavior of the cosine function. Then it's going to be our final solution for step number 1. Then x represents pi over 2, or the complete solution becomes 2n pi. N is a natural number, integer, 0, 1, 2, 3, 4. And pi, you know, it's easy, 3.14. Okay. Now, by solving this, I only solved the fact that a was going to 0. It means that cosine x goes to 0. However, I'm left with the second part, which means that the b can just go to 0 then. Now, guys, any questions up to this point for the first step?
No.
How about Ferris and Gloria?
No.
Are you sure, Gloria?
Yes.
I'm so glad that you're confident that there is no question. How about Ferris?
No.
Okay. Are you sure, Ferris? Did you check those videos from 2 days, from Friday and last Monday?
Oh, yes.
Okay. Then you now have an understanding of what's happening there, huh?
Maybe I think.
Okay. If you have any questions, please always ask me, and make sure that at the end of each class, you really review this stuff. If you got into any problem, please email me or post it on the Schoology. I get back to you right away then. Okay?
Okay.
Awesome. Thanks, Ferris. You are doing a great job, Ferris. Thanks. Okay, now, oh, let me take a drink, take some water. I feel thirsty. I got thirsty. And now, what else left to do? The thing which is left to do is that we go to this part, to the second part, to solve the thing which we have in the second part, to solve it. Which is going to be part B. Once we said A is going to go to 0, which is that the cosine x goes to 0. Once we are going to say B is going to go to 0. B is 2 sine x minus 1. I'm going to go with this one. It becomes the second part of the solution. The first part was for the cosine x goes to 0. The second part is going to be for 2 sine x minus 1. And now, what else do I have here now? I have now 2 sine x minus 1 should goes to 0, which is part B of my question. Okay, how to solve this? By solving this, I mean, what are going to be the possible value of the x that if you get its sign ratio, multiply by that by 2, subtracted by 1, it gets to 0. By solving x, we mean essentially that. In order to solve it, based on all the things that we have seen, we have said that now 2 sine x minus 1 becomes 0, then one of the easiest way is that if you look at as sine x as u as a different variable, then you have 2u minus 1 equals to 0. The best way is that always to get minus 1 to the right side of the equation. Then divide both sides by u in order to isolate u on one side. And I'm going to do that with the sine x. I'm going to keep sine x here. Take it 1 to the other side, becomes plus 1. And I have still 2. But as a second step, what I'm going to do this one. I'm going to do 2 times. Then I'm going to write sine x should equal to 1 divided by 2, because I divided by both sides by the 2. Okay. Now this is the question now which I have to solve. This one is essentially the same thing, but it seems that it's easier to solve. How am I going to solve it? As before, because I have a sign ratio here, I take a look. I say if I, based on the things which I have learned, if I take inverse sign from both sides, then I have what? I have inverse of a function, which is composed with its own function. As a result, it gives me the x itself. It actually frees x from the trap of the sine x. Then what I'm going to do, I'm going to say sine inverse of sine x, it equals to what? Sine inverse of 1 over 2. Correct? Okay, now we are at the very interesting step because it's always my favorite. It seems to me I'm like the savior because I now saved x. How did I save it? Look at sine inverse and the sine x itself. Inverse of a function with the function itself, we learned it gives us the x itself. It frees x. It liberates x. Then what I'm going to have this expression. I'm going to write it here. I have now x, because that's now liberated from the trap, equals to, as before, still I have my sine inverse from the right side, or arc sine from the right side, inverse of 1 over 2. Okay, now look at this step. This step is very nice because it tells us that we have been looking for the x, and you see, guys, we have the x isolated on the left sides of the equation. When we started to solve this equation, we said that the plan is that to find the x, that its sign ratio multiplied by 2 minus 1 becomes 0. And now I get an expression for the x. But I have some problem still. Imagine you're calling me Demo instead of calling me Omid. You have to write my name forward. Then that's what I'm gonna do. I'm gonna do what? I'm gonna do the forward transformation of the sign, and I get what is the angle that its sine ratio I'm putting in a box, show that we have to fill this, that its sine ratio gives me what? Gives me 1/2. Whatever I can fill this inside this square, it's essentially the x, which is on the other square on the other side, which I had the inverse representation. This is inverse representation. This is forward representation. And both these squares represents the same x. But this one is easier. Now you're calling me Omid instead of calling me Gimo. And now that's my question for you. That's a kind of a reference angle. What is the angle that its sine ratio becomes 1/2?
Pi/6 plus 2n pi.
Fantastic, fantastic. Thanks, Rose. Here, it becomes pi/6 plus 2n pi, but I do not have enough space in this square. I say that then x, look at this. The x here, it's exactly the same value which I got it from there. Because on the left, I have inverse transformation of the same thing. On the right, I have forward transformation of the same thing. Like the backward and forward of the same coin. Then the box here represents the same thing there. Then x becomes what? Becomes pi/6. If you are there, this is correct. But now you are only in one rotation of the unit circle. You can add some flavors to that, add some peppers with, let's say, with the cinnamon to make it tastier, to add this term to n pi. I think yesterday I just called n k, but it doesn't matter, n or k, as long as they are going to be integers, this is going to be fine. Then I got to this solution, that the x it's going to be this. And as you know, n is going to be what? N is going to be 0, plus minus 1, plus minus 2, and it goes all the way to infinity. And you saw yesterday the term which is going to be 2n pi, it is essentially what is derived from, I should say, from periodicity of the sine function. And now we are done. Then the solution for this equation, it becomes pi/6 plus 2n pi. Any questions, guys, for this stage?
No.
Everyone is fine?
Yes.
Okay. Now, the thing is this, that, how about Philip and, how about Ferris and Gloria? Everyone is fine?
Yes.
Yes, Ferris?
Yes.
Awesome. Then now, guys, look at that. I got the solutions for part B. Then it means that I have two sets of solution. Set 1 is going to be x equals to pi divided by 2 plus 2n pi. The second set of solution, which are solutions at the same time, it's going to be pi/6 plus 2n pi. Then you see, for this equation, we have two complete sets of solutions. One this, which represents term A, which is cosine x. One is this, pi/6 plus 2n pi, which represents the complete sets of solutions for term B, which is 2 sine x minus 1. And essentially we are done to solve this trigonometric equation, which it was very beautiful. Everyone is fine now?
Yes.
Awesome. Guys, what time is it now? This is 12:05. Okay, do you think that's a good time to take a break? We come back to do the second question?
Yes.
Yeah? Okay, now guys, this is 12. What time is it now?
12:02.
Oh, 12:02. Then guys, please come back by 12:17. Good?
Yes.
Yeah. Enjoy your break. I see you in 15 minutes then. Everyone is back?
Yes.
Hey. Your name, guys, if you're back. That I know that we can start. There's only rows? How about Gloria and Ferris?
Yes.
Okay. Okay, let's move on to the other type of the examples. Okay, now let's solve a different equation. Guys, I think every single second that the classes goes by, you are very excited that you're just getting closer to the long weekend, huh?
Yes.
What's the plan for the long weekend? What do you plan to do?
No plan, just sleep.
Oh, just to sleep. Oh,
Yes.
nice. Me too. That's also my plan. Okay, now. Guys, now we want to solve this question, and let's see how far we can go with it. I'm just going to have this one, which is going to be cosine of 3x times cosecant of 2x minus 2 times of cosine of 3x. It becomes 0. It's very similar to the thing which we did before. But let's see how far we can go with it. Everyone can see what I have written in terms of the light. Is it visible to you?
Yes.
Okay, you see that the cosine 3x cosecant 2x minus 2 cosine of 3x equals to 2. Okay, now. What do we have here? Is going to be this. Guys, look at this one. I'm gonna do some part of it, and I do also let you do the rest of it, and I'll also give you one example today for doing this exercise. But look at this, I should say, this trigonometric equation. Again, we have two terms. One term here and the second term here, both of them are on the left side, and the right side is equal to 0, which it always makes it 0. They call that normally homogeneous equation. The homogeneous equation is always much easier to solve them, but now we want to do something different. Now, look at this. On the first term here and the second term, there are two terms, which they are exactly the same, which is cosine of 3x. Then based on the thing that you learned before, on the previous example, we say that for these type of questions, we can simply solve them by simply taking them to factor the term which is common between them. That's a kind of an instinct. You whenever you see that you have a couple of terms and all those terms, there is one factor which is common, you factor this. And that's what I'm just going to do. I'm just going to say cosine of 3x. It is factored, and I'm going to left with what? From the first term, I have cosecant of 2x minus 2, because from the other term, when you just factor cosine of 3x, you're only left with the coefficient, which is 2. And you get it equal to 0. Guys, you see again the same thing, which happened like the example which we did before. We have two terms, which essentially is like that. We have a, b equals to 0. Then we say that either a should be 0 or b should be 0 to have this, I should say, to have this identity expression to be valid then. Then as a result, as what we did before, we call the first term as a, the second term as b. It's going to be a, it's going to be b. And we alternatively take one of them equates to 0 and solve, I should say, the equation based on it. Then the thing which I'm going to do is this. I start from term a. I say, okay, what happens if term a, which is cosine of the 3x, equals to 0? Then what I'm going to do, I'm just going to come here, only solve the first part, which represents that the cosine of 3x should be equal to 0 for part A. However, when you are here, you know that if you want to use the analytic approach, you use the property of the compositions of the function with its own inverse, which in a sense liberates variable from those ratios. Because I have cosine, it is very obvious that I have to use inverse of the cosine in order to liberate and free 3x from the trap of these trigonometric ratio. Then what I'm going to do, I'm going to do this one. I'm going to come from here and say it becomes cosine inverse of cosine of 3x should equal to cosine inverse or arc cosine, depends on which one you prefer, of 0. Okay, now from this, you saw that also again before. You see the pattern is always repeated. And when you learn one, you can solve many different equations like that. Then you say that, okay, now I have cosine and I have inverse of the cosine, which is always the thing that you are so much fascinated by it, because it gives us, I should say, the x, which it means that it becomes, it frees the x, sorry, 3x, because our argument if you take a look, guys, if you take a look, you will see the argument for this function is 3x, not x. Then we have 3x liberated equals to cosine inverse of 0. You see, this is 3x. Any questions so far?
No.
Oh, great. And now, we have to, as you saw before, we have to just make a forward transformation. And we ask a question instead that what is the angle at its cosine equals to 0. We did it before also. What is this angle, guys?
Pi over 2 plus 2 and pi.
That's right. But I write it here, pi over 2. Rose, I add 2 and pi at the very end. When I'm always done, I add plus 2 and 2 and pi. It's like the flavor. For example, you are cooking, you add some salt and pepper at the end, huh? And that thing is like the salt and pepper that you shake it on the top of your food then, when the food is done, huh? Yes, Ferris Angleria? And now, look at this. I have here Ferris, Gloria, Rose. Look at this. This is a smart trick. Look at these two items. 3x and pi over 2. What do I have here essentially? What do I have here essentially is these two boxes, as we learned, they are going to be similar. Then it means that now 3x equals to pi over 2. Huh? It means that 3x equals to pi over 2. Then what do we want? We want the x. What is the x? I divide both sides by 3. Then I get x equals to pi divided by 2 times 3 becomes 6. And now that's the time we can add salt and pepper plus 2n pi. Everyone is fine?
Yes.
You see, that was a trick. At the end, we got the value, the angle. It becomes what? It becomes this value. Remember, the things that we obtained before, it's for 3x equals to pi over 2. But now, as I said, we are looking for the x. Then we have to divide both sides by 3. Then we get x should be necessarily pi divided by 6. And the salt and pepper is always for sine and cosine that you add at the end is going to be 2n pi. Any questions?
No.
No one? Ferris and Gloria? Maybe they stepped away for a second to drink some water. But now, the other thing that we want to do is that by solving this, we only solved part A. Part B is still left, which means that we have to equate B equals to 0, which it becomes what? Which it becomes cosecant of 2x minus 2 should equal to 0. Because either A goes to 0, which it was cosine of the 3x goes to 0, or cosecant of the 2x minus 2 should goes to 0. And that's essentially the plan that we want to do now. Okay, everyone is fine now? It was cosecant of 2x, huh? Am I right, Rose? 2x minus 2 should equal to 0. Okay. Now, it is exactly because we want to follow. Give me 1 second. I open the door. It's getting a little hot in here. I come back in a second. Okay, now, the thing that we do is this. In order to solve it analytically, that's not something new to us. We say that the cosecant of 2x should equal to 2. It's very simple. I took 2, which is on the left side with the negative sign. I take it to the right side. It passes, I should say, the equal sign. Then it becomes plus. And now, what needs to be done in terms of the analytic solution? I know that also we saw that, I should say, on a week ago, that we can still use the inverse of the cosecant function in order to liberate the argument which is inside, I should say, trapped by the cosecant function, by writing the cosecant inverse or arc cosecant of what? Of cosecant of 2x, and also the same thing to the other side, cosecant inverse of 2, because the right side there is only one number, which is 2, which it means that when you take from both sides inverse of the cosecant, you are only taking the cosecant inverse just from number 2. Now, okay, this is my favorite part of the whole equations, trigonometric equations, because I'm like the savior to save and liberate 2x from the trap of the cosecant function, because now it is faced by the cosecant inverse, which is now becomes, it frees that to becomes 2x now. Cosecant inverse and cosecant, they get dissolved into each other. They liberate the 2x, and I have 2x only left from the left side. And as you can see, I have only from the right side cosecant inverse of 2. However, guys, you know that in order to answer this, we are just going to move backwards and make a forward transformation and ask ourselves, what is the angle that its cosecant becomes 2? And it's very easy to find it. And also, you know that. Let me sip on my coffee. X, and the same box there. That's backward transformation. That's forward transformation. And now, in order to solve this, what is a cosecant? What angle's cosecant is 1 is 2? in order to answer it, it's not easy to work with the cosecant or the secant of an arc because they are the less ratios that we normally work with them with the functions and advanced function courses, or even when you just go to the calculus class. But always we remember that the cosecant of x is the inverse of what? You remember that, guys. The cosecant of alpha is what? It's the inverse of the sine, huh? Sine alpha. Do you remember that? Rose, Faris,
Yes.
Gloria? Yeah? And look at that. If even I do not have the calculator, for example, Desmos, they have a scientific calculator. You can get the value for the inverse of any functions with the Desmos. If you Google it, Desmos scientific calculator, you can just type inverse of the cosecant and it gives you anything. But this one, we do not need even to use that because we know that the cosecant is the inverse of the sine. And we know that the cosecant of that mysterious angle is 2, which it means that if the cosecant is 2, the sine of that angle has to be 1 over 2 because 1 divided by 1 over 2 becomes 2, huh? It's obvious, huh? 1 divided by 1 over 2, you get becomes 2, huh? Then essentially, you can, as many are answering this question, that what is the angle that its cosecant becomes 2, you can ask the same question, what is the angle that its sine becomes 1 over half? Because they are the cosecant and the sine are the inverse. If cosecant is 2, it means that the sine is going to be 1 over 2. And what is the angle, guys, that its sine becomes 1 over 2? That's a reference angle. We talked about that before.
Pi over 6.
What, Rose?
Pi over 6.
That's so true. Then we know that the angle has to be necessarily pi over 6. Because the sine of pi over 6 becomes 1 over 2, then its cosecant, which is the inverse of the sine, becomes the inverse of 1 over 2, and the inverse of 1 over 2 becomes 2, and it means that we solved this part. However, as a very final touch for this equation, we're going to come here and say that, look at this, guys. These two boxes, which I connect them with the green light, they are essentially the same box, the same thing, which it means that whatever is inside in this box should be inside that box because there are two sides of the coins, the forward transformation and backward transformation of the same quantity. And as we saw that before, it means what? It means that then as a result, now I have 2x should be equal to pi over 6 because this box, which is pi over 6, represents 2 times x. Then as a result, what do you get? You divide both because we're looking for the x, not 2x. Then in order to get the x, what do? I divide both sides of this, I should say, expression by 2. Then from the left, I get x. From the right, I get what? Pi divided by 6 multiplied by 2 becomes 12. Huh? Then you say that I have x, which is with the coefficient 1, with the power 1, and that's exactly what I wanted to obtain from this identity, from this equation. That was all the plan, to find what is the value for the x. Then at the end, you say that it's going to be plus. It's going to be a kind of a salt and pepper that you have, plus, let's say, for example, 2n pi at the end. It's not as important as pi over 12, but all the thing that we need is going to be this expression. Pi over 12 is going to be the solution for this equation. And now, guys, look at this. Now we are done. Now we have an answer. Pi over 12 is a principal, they call that principal roots of this equation, which is cosecant of 2x minus 2 equal to 0. However, pi over 12 plus 2n pi becomes the complete sets of solutions for the same equation. Then you can think of it as two things. One, you look at it as only one term. Let me highlight the periodic behavior with the blue circle. You can think of pi divided by 12. We call that as a principal root of this equation. But when you add the salt and pepper, which is 2n pi, the whole terms, which is pi 12 plus 2n pi, we call that the complete sets of solution, because it gives all infinite number of the solution which satisfies this equation. Make sense, everyone? Any questions for this part?
No.
No? Philip and Ferris? Oh, sorry, Ferris and
No.
Gloria. Ferris said no. And Gloria, are you there, Gloria? Then, guys, you will see that in
No.
order to solve this equation, which it was cosine of 3x times cosecant of 2x minus 2 times of cosine 3x equal to 0, we inevitably decompose that into two equations, two terms, which the solution for cosine 3x gave us pi over 6 plus 2n pi, and the solution for term B, which is cosecant 2x minus 2, gave us pi 12 plus 2n pi. Then we have two complete sets of solution. One is pi divided by 6 plus 2n pi. The other simultaneous complete set is pi divided by 12 plus 2n pi. Then we have two sets of solution for that equation. It's so beautiful, guys. I really love, I should say, these kind of equations. Okay. Now, what else we have? Okay, we have this. Huh? Okay, now we have one very easy one. I give that to you to solve it, then I help you. Then essentially we should be done and celebrate for the long weekend. Okay, this one which I'm going to give you is also very interesting because for two reasons. The first reason is that that's the last example, and this is the before celebrations for the long weekend, and also because it involves a very easy trick, but that trick is life-saving. Let's see. We have cosine square root of the x minus sine square root of the x equals to what? Equals to 1 over 2. Okay, guys, spend 5 minutes, I think, maybe 5 minutes should be fine, that you see what kind of a strategy you may end up with to solve this trigonometric, I should say, equation, which is cosine square root of x minus sine square root of x equals to 1 over 2. I want to interrupt a little, if you don't mind, then we continue that together, huh? Is it fine, everyone?
Yes.
Yeah? Okay, thanks. Look at that one. This is cosine squared x minus sine squared of the x equals to 1 over 2. Guys, what did you think initially when you were faced with this equation? What is your first step strategy? Step number 1. Rose, Ferris, and Gloria, what did you think initially when you look at this function? Rose, how did you start at it? Rose?
I have no
What?
idea.
Oh, you had no idea. Guys, look at this. Then this is good that I interrupted to just let's do that together. Okay, look at this one, guys. Gloria and Ferris, are you there?
Yes.
Yeah, glad to hear it. Guys, look at this one. This one seems a little bit, I should say, challenging initially, but look how easy it can be. The left side, look at the trick, which I'm going to do. It's going to be a very good lesson that we can start from that next week, Tuesday. And let's see, Look at this one. Previously, we saw that when we talked about the trigonometric identities, we came to talk about something that we said that cosine of alpha plus beta, it can be extended as cosine alpha cosine beta minus sine alpha. Guys, sorry, I just got small space. Then I hope that you see that, but that's the thing which we covered before. We have said that the cosine of alpha plus beta, it is cosine alpha cosine beta minus sine alpha sine beta. Once we came to say that what happens if alpha should be equal to beta, then we saw that this one becomes interestingly very easy identity, and it turns out to be, they call that cosine of, let's say, alpha plus alpha becomes 2 alpha, or beta plus beta becomes 2 beta. It doesn't matter. I'm just going to use alpha instead. Then we saw that cosine of 2 alpha becomes cosine squared of alpha minus sine squared of alpha. You see, because becomes cosine alpha becomes cosine squared of alpha minus sine alpha sine beta becomes sine squared sine alpha sine squared of the alpha. Then based on the thing that we saw before, this identity was derived when we were working on our scenarios on the trigonometric identities a couple of weeks ago. Then, guys, please look at this one and compare this to this. I have cosine of 2 alpha. I derived as a cosine squared of alpha minus sine squared of the alpha. And look at this one there. Aren't they the same?
Yes.
Yeah? Then I can write it like this. Instead of writing cosine squared of x minus sine squared of the x, which is a hell of a job if you want to solve the equation without transforming it to this identity, then it can be changed as the cosine of 2x equals to the right side of equation 1 over 2. Guys, you see how beautiful it got? A long-term expression, which is hell of a job if you want to solve it without this identity, it's simply reduced to one simple, neat equation, which is this. The cosine of 2x equals to 1 over 2. You see that now? Yeah? Now, everyone is happy so far? Everyone understood what happened?
Yes.
Yeah? Okay. Now, guys, look at that. Again, we have the same scenario. You see, solving a trigonometric equation is very easy, as you may not have expected that. It becomes very easy in a sense that you take the cosine inverse from both sides in order to liberate 2x, which it means that I can write it as the cosine inverse of cosine 2x equals to cosine inverse of 1 over 2. And now look, what time is it now? Oh, we have almost 12 minutes. Look at this one. Cosine inverse of the cosine of a function, which is a fascinating part of when you solve a trigonometric equation. When you see this kind of stuff, you should be very happy because you are not in trouble. You reduced your equation to an algebraic one. Then you get what? You get cosine minus cosine inverse of cosine of 2x becomes 2x, because the argument of the cosine x is liberated, becomes what? Becomes cosine inverse of 1 over 2. Now, you want to ask yourself, what is the x? Because it was a purpose. What was a cosine inverse? We just want to say, okay, we do not want to deal with this problem right away. We have to just, I should say, do that the forward transformation. We want to ask ourselves the question, what is the angle that its cosine of that angle, if I have it like that, the cosine of that angle becomes what? Becomes 1 over 2. Oh my God, we had lots of examples of this. Which you remember that. That's the third time we end up with these questions. And what is it now? You can close your eyes and say, cosine of pi over?
Pi over 3.
3, that's right. That's pi over 3, that its cosine gets you to 1 over 2. And let me also show you this, that the thing which we got, it represents this. It's very crucial, guys. You know that the thing which you got, pi over 3, it's not for the x. It is for 2 times x. It is very important that you realize that the pi over 3 which you got over here, it doesn't represent the x. It represents its counterpart, which is 2x. That's what I want to do. If I write here, you see that's what I'm writing here?
Yes.
Then what does it mean? It means that 2x should equal to pi over 3. You see that now? Which it means that if you divide, because we are looking for the x, we say that the x then becomes, you divide both sides by 2, becomes pi over 6. And at the end, you can add salt and pepper as 2n pi. Pi over 6 represents the principal root, but pi over 6 plus 2n pi represents the complete sets of the solution for this equation. Guys, any questions for this problem?
No.
Thanks, Rose. How about Gloria and Ferris?
No.
No? How about Ferris?
No.
Thank you, Ferris. And guys, we are almost done. We have nothing else to do. We are going to finish the class, but I have to remind you of three important things. The first thing is that the deadline for your inverse trigonometric function is due by Sunday midnight. I'm going to also post some very easy trigonometric equations homework for you tonight, which its deadline is going to be due by the next Wednesday. By the next Wednesday, you have enough time. And also the third thing is that, guys, and also good luck for your presentation, which is going to be due all of you by next week. Then it seems nothing else to add, unless if you have any questions. Any questions, guys?
No.
No? Then, guys, enjoy your time. Enjoy your very long break, with the long weekend. Then I see you all back by Tuesday. Don't forget about your homeworks. And also don't forget to submit that to me by Sunday midnight. And don't forget to work on your project. And if you have, in the meantime, any questions about your homeworks and about your project presentation, make sure that you send me an email or post that on the Schoology. I'll get back to you right away then. Okay, guys, if you have no questions, then have a very long break. Enjoy your break and long weekend. See you guys next week, Tuesday. Bye, everyone.
Goodbye.
Bye, Rose. Bye, Gloria. Bye, Ferris.